think you had like two A's and a B on exam, and then finally you like make an F. That'll give you like a C plus, right?
Kind of, it's kind of like half.
It makes sense.
Format.
You had to go from math to be the method, anyways.
To quote, I didn't.
We don't have to go in the same order. We can jump to a later question, come back. I'm just solving them one by one because you're not requesting any special question, okay? So feel free to jump if you have, oh, I didn't do 39. We can start with that. All right. Still no? Number 16 is about finding maximum and minimum of functions. Maximums are the summit points, like these are mountain-looking objects. So you're gonna find the highest point, biggest elevation on this path. That will be your maximum, or maximums, okay? Can be more than one. And minimums are if your function takes a dive and turns back up again, makes a U shape or V shape. There on the bottom you have a minimum. Okay? So going down and going up, you have a definitely minimum there. If you are going up and suddenly turn down, there is a maximum there. So just imagine yourself, you're on this. You're walking and walking and walking. Whenever you start sliding, so you're climbing, 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 climbing. Suddenly you're starting going down. There you stop and there is a maximum. And you go down, slide, and suddenly you start increasing. There is a minimum. Go up and suddenly you turn down. There is a maximum, and there is no more maximum or minimums because you're forever sliding. So, from my explanation, can you tell me if this function has any maximums or minimums, or how many?
Two maximum, one minimum.
Yep, two. Oh, this is for minimum. So there is only one minimum right here. You're going down and going up, and two maximum because you were going up. Turn down. This is a max. This is a max as well. So every bump makes a maximum. Every cavity makes a minimum. That's it. All right, we need to locate them, tell where their x coordinates are. So maximum first, they are at here, right? Go down and smash this to x-axis, -1 and +1. What? Oh, because the question is not over. Well, what is that maximum value at -1 and 1? You're gonna measure the elevation of this mountain from ground. It's 1 box, 2 box, 3 boxes. So this y coordinate of the maximum is asked, so it is 3. Right? All right. Someone want us to answer this question. And minimum was at 0, right? And the minimum value were, okay, this is minimum. Its x coordinate is 0, y coordinate is 2. Okay? So this is easy. Any questions on number 16? All right, moving forward. All right, let's remember step functions. What's the other way to call this? This is called step function. There is another name for these. Anyone recalls? Nobody? It's called step function, one name.
Isn't this when you like go into the highest nest ever?
Mm-hmm.
So that was like,
What's the fancy name to call it? It's called greatest integer function. That's the second name, or the third, actually, the best name may be floor function. This function, whatever number you enter here, it floors it. That means it rounds down to the nearest whole number, rounds down always, not up. Okay? Like even this is 2.999, you don't round to 3, you round to down 2, whole number. So what is floor of negative 0.83?
-1.
Yep, you round down. Just imagine where negative 0.8 is. Literally sketch it. If this is 0, this is negative 1. Negative 0.8 is before or after negative 1? Which side is after? I mean, to right or left, it's right, correct? Right. So when I say go floor, pick the smaller number, you go left. You always go left. So this guy chooses always left side of the number, so it is negative 1. So if you know what this function does, this question is only 3 seconds. Okay? Is it clear? What if this was positive? Let's check. Let's check something quick. What if this was positive? Answer is 1? No. 2? What's that 2? Okay, there are different answers.
Oh no, I
here.
lied, it's 1.
Okay.
0, is it?
No, floor again. We are always picking one of these values will be picked, but we always pick the smaller side, smaller value. Although this is 4, we still go to smaller values, okay? Don't do 1, it's 0. I'm glad I asked this. Okay. It's 0 if it is 0.83. Okay? If you don't have any questions, we are going. Oh, what if it's a whole number? Let's do one more. Like this is 5. But what if it is right whole number? Let's just find that. If it is a whole number, it's itself. Okay, you don't have a choice there. So it's always smaller or equal to itself. All right. Next question is about what is this operation between P and Q? It's multiplication. There is a similar operation. Some people may confuse it with this. What is this one called? If you have a round circle instead of a dot, this is composition. It's a whole different idea, okay? This is product. Product. They want us to just take product of P and Q here, right? Yes, find function P times Q. So you will never get to use this. Cover it. And write in its domain. Maybe the second part might be harder for you. We're going to also write its domain in interval notation. Let's first multiply them. It says multiply P, Q. That means literally put X in P and in Q and multiply them. So you will take whatever you see in P right here, whatever you see in Q right there, and join them with a dot, multiplication. But when you're doing that, be careful. Is this correct? Is this correct writing? What is wrong?
Parentheses.
Yeah. This is a two-term subtraction, single term. If it was single, you could put a dot, you're done. But this is two-term multiplied by another term. You need to use a parenthesis around the first one. Well, do we need to literally distribute this over these guys? Not necessarily. You don't have to. Not have to. If you do, that's fine. Since there is no more simplification when you pass, when you distribute, I won't do that. This is going to be my first part answer. So take a parentheses, put this down. And you don't need a parentheses because square root kinda packs things. If that square root wasn't in there, only 4 minus x was present, I would use also parentheses around it, but right now you don't, because square root is itself acts like a parentheses. Now we are going to find domain of this thing. Again, domain is the list of all numbers from negative infinity to infinity. Only those you plug in this box in x, and in x here, here, and there, 3 spots, and all these must be computable. Your function should turn into another number like 5, 5, 5. Can you compute it? 2, 2, 2. Can you compute this number? 0, 0, 0. Can you compute that? If you catch anyone not computable, then we exclude it from the domain. Okay? Are there such number or numbers we must avoid? Anything greater than 4? How'd you get that?
The square root of 4 minus x.
Yep.
So if you subtract anything over 4, it'll be negative, and you can't take the square root of a negative number.
Good. Just let's start the weak guy. This is a weak function. What do I mean by weak? It's fragile. It can break down any moment. How about this one? This is a strong part. But are there any values you plug in here and you cannot compute? No, I can always square a number and multiply by 7 and subtract them all the time. This is strong, never breaks down. So domain of this function is everywhere. What makes this whole function weak is this weak guy. There is a weak link here. 4 minus x under square root sometimes is not computable, especially if you get a negative answer. So we need to focus on 4 minus x. That inside must be either 0 or more all the time. Because domain is asking good values. I know the bad ones are negative, so good ones are the ones making this thing positive. So I'm setting this positive, more than 0, and solving it. And I will find out what numbers make this thing positive all the time. So you said anything bigger than 4 is bad, so my answer should be anything less than 4, or equal to 4, right? Okay. So let's work this out. And I have minus x greater minus 4. I'll multiply both sides or divide both sides by negative 1. Cancel, cancel. Nope, my good list is every number more than this is canceling to positive 4, right? My answer is everybody more than 4 is good.
You have to flip the side.
Yeah, because I forgot to flip. Should be less. Why? Because when you divide or multiply both sides with a negative only, negative number, and you flip. Now our answers match. I'm saying anything less than or equal to 4 is good. She's saying anything more than 4 is bad. We are matching, okay? We need to think the good side because domain is good numbers. So, but how do you write this? How do you write all numbers less than 4? So here is 4. This means less equal. I need to include 4 and take everything less. So this side, starting with 4, is my interval. Less means left of 4 up to unlimited. So this thing is in interval notation, negative infinity to 4. Okay? Make sense? Any questions? Remember, we are doing a review. We will never ever be back to this, so this is the time to ask questions if there is a missing spot. All right. All set. Let's done the infamous circle composition operation. So don't just multiply those two formulas. It's not going to work this time. This is composition. Why don't you guys give it a shot and tell me your answer? Q compose M. Order matters. Anyone?
Don't you put the M in the place of the X?
Yeah. So what is it? What is it?
Y
Or
Q
circle mx equals what?
1 over X plus 9 square root X plus 9
Mm-hmm.
minus 2.
Any objection? Any different answers? Okay, let's check. I'm starting with definition of Q, what Q circle M means. Q circle M means M is going into the belly of Q. So you're making Q, but instead of Q of X, M is going in, M of X entirely. So you simply put X in the center and then M and then finally Q. We start inside out. X is first visiting M. So there is a material X visiting M machine and processed by M machine, and M is turning it into an output, a new product. And that new product will go into Q, and Q will process it. So let's see first what happens to X if it's processed by M. So process X with M. How? It says here already, if X is processed by M, it turns into no longer just X, it gets a square root and added 9. So that's what I'm going to do. First step is just wipe this off and read its formula, that is X plus 9 under the square root. Okay? So M of X is gone. The material X turned into transformed into a brand new thing. Square root X plus 9. We used to have only X under Q. Now you have something mutated, completely changed. How do I compute Q of something else? It's not just X, it's something else now. If you see X, you make X here. If you see something else, you make something else everywhere here. Even a turkey, right? We gave that turkey example. You see a turkey here, you put the turkey there. That's it. So this is your turkey. Use it everywhere you see axis. And that's only one spot in the denominator here. So I'm making this turkey here. Take 11 off. So the answer is right. However, that was the easy part, maybe. There is a second part of the question. You will not only find the domain, but also change it into interval notation. Kind of previous question. Previous question for this formula this time. Take this formula and imagine when you can compute all these values and when you cannot. We need to take the good side. When can I compute the square root and take 11 off from it, and this 1 over of that number makes still sense. It's not going to be undefined. Okay? Let's first try this. Okay. What is it? Anyone have an idea about the domain of this thing? Or this function? What values am I allowed to enter in X? It's just like the previous question. Instead of X minus 4, you have X plus 9 now. What are the computable values for X? Negative 9? Just negative 9? Only negative 9? If I put negative 9, it's 0. Yeah, I can compute it. That's it? There are more, right? Which side of negative 9? More than 9 or less than? More than negative 9 or less than? Less than. Okay. So, this guy is a weak function. We need to make this happy inside happy, which is X plus 9 needs to be more than 0. This implies, oh, I need to pick always my numbers more than minus 9. Fine. We've got this result. This one now, if you supply these values, it's happy. This one is happy if you give anytime more than negative number into that function. There is another weak function here that can break down any moment. Where is it?
The denominator can't be 0.
Right. This fraction has a weak spot, which is the denominator. If this denominator becomes 0, you're in trouble. So the second function you need to keep happy is the denominator function, the fraction, and especially the denominator. This needs to stay off being 0. You cannot have it 0. This guy must be always non-zero. Well, I will just solve this as if 0, and in the end I will just say no, not equal 0. So add 11 to both sides. Right? Look, I'm just solving this as if it's an equal sign. Now how can I get rid of that square root? I will square both sides and that will take care of the square root. Well, 11 squared is 121, and I will subtract 9. And we will have x as not being equal 1, 1, 2. So, this function was happy for x is greater than minus 9 Now this function, this entire function is happy if you avoid x being 1, 1, 2, because in this set, look, all numbers more than -9, you have 0, you have 10, you have 100 here, you have also 112. So the bad value for this function is in here. So when I exclude that as well, everybody will be happy now. So let's take a look at this in the picture. So first function says, give me all the values more than -9. Where is -9? Here. As long as you give me a value from this green zone, I'm smiling. This function says, yeah, I like the green zone, but don't give me 112. So what I do is, I punch a hole right here. Okay, take a hole. And continue with this. So what is your final domain then? Combination. You need to keep both happy. It's this green zone without the value. But how do you write it up? How do you move this picture into mathematical terms in interval notation right here?
-9 to 112, 112.
Okay, hold on, let me write. You're saying this part is bracket or parentheses? Bracket. It's bracket already. 112,
Yeah.
bracket,
Parentheses.
parentheses, and then?
Gonna be hiding,
Mm-hmm.
and then 112 is number.
Good. Can I include 112 to any side? No, if you include, it's gonna make the big function sad. So we should take 112 off by splitting into 2 pieces. This is the second piece. Okay? All right, this finishes off number 19. Two function graphs given. We are gonna, I believe, find out 6, 7 values of the function and maybe compose them. So let's do this on the screen and take a look at what is asked first. You are finding some of these functions at -1 first. So part A means find h plus k at -1. This means find h at -1 and then find k at -1 and add them up separately. Okay? So what is h of -1? Which one is h? Blue?
Blue.
So find -1 first on x-axis. Here is x-axis -1. Go up, hit the curve. When you hit the curve, go towards y-axis. Y-axis on the right, and spot that value. That is h of -1, which is 2. How about k of -1? You do the same thing for red curve. Go start from -1, hit the red curve, and you hit the red curve, turn towards y-axis, hit the y-axis, it's 3. -3. You're adding them up. What is 2 -3? Good. That's the first one. Alright, you repeat this now with subtraction and add 4. So it is h minus k at 4 means you compute h of 4 first, k of 4 first, and subtract. Alright, we're doing this all time. You start at 4. Where is 4? Right here. You hit below curve first. I'm going down to hit below curve because it's downstairs. And then turning left and computing y value of it. Oh, -1. We're restarting for red 1. I don't have to go up and down. I'm already on it. So you're not moving a bit. You're not moving at all. Because you're already on the red curve, which is k. So if you hit it, you turn left and mark y coordinate of that point, which is what? 0. -1, take away 0, -1. Okay? Make sense?
It was k minus h. We did h minus k.
Alright. Thank you. This was b prime. B is k minus h actually at 4. Well, guess what's going to happen? These two will flip. So it's going to be 0 first and then -1 next, but subtract it. So the answer becomes +1. Technically opposite of this number. Good. See, you're dividing them at -3. Order matters. Which one is on the top? K. K of -1, h of -1. Was it -1?
-3, I think.
-3. Alright, let's track the values at -3. Where's the -3? Right here. Oh, I'm lucky for the blue one. I'm already sitting on top of blue. I don't have to move an inch. Just go hit y value 0. No matter what you get, as long as the bottom is not 0, I know the answer is 0, but I need to make sure. H of -3. This time hit H, go right. It's -3. Yep, negative. I don't have to write twice. 0 over a number, non-zero number is 0.
I think the blue line's h, so it'd be undefined.
I do keep doing this in the wrong order, yes. Yeah, the whole story changed now. K is red one, so it's -3. Blue one is H, 0. Yeah, if 0 is on the bottom, number on the top, this is a whole new story. It's called undefined. Right, this option. HK multiplied. Look, you don't have to reinvent the wheel. It says multiply those two values, H and K. So just cheat the values here. What is H of -3? 0. K of -3, 3, -3. What is 0 times anything? 0. This thing is 0. Okay, finally we have the compositions. These are the challenging ones for you guys, right? Do you remember how you do this? A K circle H0. I just flipped the notation to this one. They are the same, look. K circle H of 0 means 0 is first going to H and then compute it under H, get a new value, and you're going to compute it under K. Let me say it again. 0 shall be computed in H first and will become a brand new number. That brand new number shall become another number under K. You need to compute it, okay? So just tell me, what is H of 0 unless we haven't found it before? Nope. H of 0 is, you're at 0. You need to hit H. Which one is H? Blue one, right? Go up. I hit it. I don't have to go move and right because I am on Y already, and which is 3. And now I need to compute that 3 under K. 3 will visit K. Where is 3? Right here. Where is K? Down here. Hit it, turn left, which is -1. All that. It's just double process of material. Material goes to machine 1, turns into a new material. That new material goes into second machine, turns into final product, -1. Am I right? HOK at 1. HOK at 1. This. Any results? Two. All agree? Let's compute 1 under K first. Where is 1? Here. K is down here. Compute it. It's -1. Now -1 is going to visit H. Where is -1? I'm taking brand new -1, visiting H. Yep, 2. Okay? And finally, we have 2 going into K and then going into H. Let's do this quickly. 2 going into K, -1, -1 going into H, 2. Can you follow? H, K, 2. What is K of 2? Here's 2. Visit K. Oh, it's still -1. Take this -1 on X now and visit H. It's 2. Okay? Make sense? Take the first X value, compute it, and take that Y value, put it on X, and compute it again. That's it. Okay. Oh, I know. There's no way we can finish this today. So, this is a good start. Take a break for 2 days and we'll continue on Monday.